Okay, here is part 2. I'm going to try to go a little bit more quickly than I did on the previous section because this video might be a little long. So we've already covered the first just sort of introductory equations for linear and exponentials. Let's move to number 4. The price of gallon of milk is increasing. Okay, that word is important. So increasing means going up. That means we're going to add, or there's going to be some addition involved, at a rate of 2%. Okay, this is also important. We have a percent. If you ever have a percent, then you know it is that one and only formula that deals with a percent. What is that formula? It's on page 1, but let me write it for you here. 1, this is going to be plus because it's increasing, and then raised to the x. Okay, let me keep reading. If a gallon of milk costs, oh my goodness, I've got a mistake. This should be $3.50 in 2016. Write an exponential function. Okay, so here's the basic function, and we just need to plug in. A is your starting value. So milk started at $3.50. So $3.50 is our starting value. We're going to have 1 plus our rate. Now, let me go over here and remind you, 2% is out of 100. So the way you convert a percentage to a decimal is divide by 100. What that's going to do is it's going to move the decimal 2 places to the left. So your rate would be 0.02. You cannot plug a percentage into the formula. So right here, I'm going to put 0.02, and then this is raised to the power of x. Make sure you put your x at the top. So this is the formula that would be used for this particular problem. B, how much will milk cost in 2020? Okay, so let's see. We started with 2016 and we're going all the way to 2020. So we will subtract there, and the time is going to be 4 years. There's 4 years that they're asking us about. So I go back to my formula, and it's going to be $3.50 times 1 plus 0.02, and it's raised to the 4. X is time. Now I'm going to use my calculator. Don't forget, you have to follow the order of operations. So first we do what's in parentheses, then we raise it to the power of 4, and finally we multiply by $3.50. Now this is money, so I have to round to 2 decimal places. We are having some rounding issues in this class. So the answer is $3.79. Okay, that is how you would round it correctly. It's not 78 cents, it's not 80 cents. $3.79. Number 5, you buy a car for $330 per month with a down payment of $400. Write a, okay, key word here, it says write a linear function. So that's how I know that it's a linear equation. So I'm going to jot down my basic formula, which is y equals mx plus b, and I'll decide what my m and my b are. So let's plug in $330 per month. This is your rate, okay? This is the number that changes. Every month you add another $330 to your pot. So 330 is m. This is your slope. M is followed by an x. And then at the back, you put this b. This is your Y-intercept, or your initial value. This is what you put down on the car initially to just drive it off of the lot. So 400 is your initial value, or your b. How long will it take you to pay the car off if the total is $16,240? Now, listen up, because this was a little bit different. We don't know how long. We're trying to find out how many months it will take us if the total of the car is $16,240. So this time we have to put the $16,240 in place of y, not x. We're trying to determine the number of months. The number of months is x. So now I'm going to solve this little equation. The opposite of adding 400 is subtracting. So this is going to come across the equal sign, and it'll be minus 400. So 16,240 minus 400, 1,000. Sorry, I'm not that good with algebra. 15,840. And then that equals 330x. The opposite of multiplying by 330 is dividing. So I divide both sides by 330, and I'm going to get 48. So X equals 48 months. Now, 48 months is the same as what? That is the same as 4 years. Now, after this chapter, we're going to move into a finance unit about, and buying a car is one of the things we're going to discuss, but 4 years for a car payment is fairly reasonable. Let's move to number 6. The balance owed on your credit card triples. Okay, this is a great example. This is a key word here. When you hear the word triple, then you automatically know that you have an exponential equation because that word is a multiplier. For 9 months, if the balance is growing linearly, on the other hand, if the balance is growing exponentially, again, we have an exponential formula. Here it is right here. This is our formula, and we're told that it's exponential. What would the balance be after 46.1 months? So what we're going to do is we're going to plug in 46.1 to our function. This is function notation, 1 plus 0.13. And you plug in 46.1 up here. This is an exponent. Now, let me refresh your memory. You have to follow the PEMDAS. So P comes first. Do what's in parentheses first. So add those together. And then second is exponents. Exponents come second in PEMDAS. So the second thing you will do is raise this to the power of 46.1. It's not multiplying. And then the final and third thing you'll do is multiply by 800. So just keep that in your calculator and multiply by 800. You do not want to round at every section. You want to wait till you get to your final answer to round. So the final answer is, we're talking about money here. So it says round to the nearest cent. That's 2 decimal places. $223,875.33. There is no other answer other than that. That would be accepted. Any other rounding is incorrect. Number 7, find the slope and y-intercept of the following linear equation. Okay, it says express the y-intercept as a coordinate. So here we go. We've got y equals mx plus b. It just so happens that this is a subtract. So our m is 1/4. Our b is -7. So slope is 1/4. That is the slope of this equation. And the y-intercept, m is the slope, also known as the rate of change. The y-intercept is -7. Now they want you to write that as an ordered pair. -7 is your y coordinate. This is the y coordinate, and that means you would put 0 in for your x coordinate. The y-intercept is also known as the initial amount. That would be your starting value. Number 8, the population is decreasing. Okay, key word here. This means it's going down. This means it's getting smaller. This would be a decay problem because the word is decreasing. And so this is going to be an example of a decay at a rate of 2%. Well, when you see a percent, you do not need to think. You automatically know that it is your percentage formula, and this is the only formula I've given you that has a percent in it. So we're definitely going to use this formula. And the population today is 27,200. So y equals, your initial population is 27,200. We have 1 plus or minus our rate. Now be careful here. Let's go over here. We know that, scratch that out. 2% divided by 100 would give us 0.02. This is our rate. You must convert your percentage to a decimal. Now, because it is decreasing, I'm going to have a subtract in the middle. This is a decreasing problem. It is decaying. The population is getting smaller. So put 0.02, and then you're going to raise it to the x. This is the formula for the population over time. Now we're going to use that formula to answer part B. It says, what will the population be in 10 years? So plug in 10 to your formula. Make sure you follow the order of operations. Parentheses first, exponents second, and then the final thing you'll do is multiply. So let me plug this in right quick. 1 minus 0.02 raised to the 10th times 27,200. I'm keeping that in my calculator the entire time. Now, read your wording. It says round to the nearest whole number. That is because we are talking about people. We are talking about human beings, actual lives, and you can't have a decimal of a person. So it's going to be 22,224 people. There will be no decimals there. We're going to round it to 22,224 people. Okay, I think I'll stop and do one final video because I don't want any of the videos to be too long. So I'll be back with part 3.